So, what have I made? With a little more detail than that. So, we have one curve-based bridge, 5 models, 19 materials, 6 animated materials, 8 PBR materials, 3 Niagara systems, 1 procedural Ivy system, 1 procedural bridge system, and 2 blueprints. So, we have 3 Niagara systems. 2 are very simple, 1 is very complex. We'll start off with the simple one against the complex ones. So this one was fairly simple. This is for the start and end of the shield when it spawns and breaks. So it literally just it's 2 particle systems that throw things out. One's the hex one, one's the simple particle. Now, the particle one's interesting because the faster it goes, or the higher the velocity that we calculate in the scratch pad, the longer it gets. And we have to calculate it in a scratch pad because velocity normally is a vector. We want it as a float so we can do a multiply with it. So we use a scratch pad. Alright, now we have the blood spatter one, which is the same burst sort of thing, but it has 3 sort of things to it. It has the usual blood spatter, just blood particles going everywhere, and it has the darker ones. Darker ones are interesting because when they hit the wall, their gravity value is changed, and then they go slower to try and simulate sticking. The normal red splatter particles, when they hit the ground, they die. On death, they initiate the spawn of decals on the ground. Those decals, there's 2 of them. You have the stationary ones and the moving ones. The moving ones have gravity on them and they go down. Then those spawn the stationary ones to leave a trail behind. There's also weird pop-in when the moving one gets dies. You can see behind it because transparency in his engine is weird. You'll also find out that decals don't interact with transparency at all. Partially because transparent things don't put any information onto the depth pass by default. But also there's some weird thing where they don't initiate the transparency at all. So, for this Niagara system, we have 3 things at play. We have the impact effects, the fireball effects, and the smoke effects. The fireball is fairly simple. There is an attraction force on the player, or the character, and we just start throwing fireballs at it. The fireballs being a mesh, and then we put a little line behind it. So there are 2 systems at play here for the smoke. The first one is fairly basic. It spawns smoke where the fireball was, and then just uses gravity to go down. The second one is attracted to the fireball that spawns it. It's a bit more unique. So for this puzzle I tried many different techniques. From updating the position from the last spawn particle to using a location event system. None of them worked, but I did get one that did. So in the scratch pad there's a function called the particle attribute reader. What it can do, as it says from the title, it can read an attribute of a particle and keep it updated. This allows us to grab the position of the particle using the ID of the particle, using the ribbon ID. So we know the position of the particle that spawned the particle from its ID. We can grab the position. We take the position of the particle we spawned from the position we want to be in, so the mother particle, and then we get the vector to it. You'll also notice there's more than one fireball. This is because, using the same attraction system we've already created for the smoke, we added a sub-mother particle or sub-fire particle that does the exact same thing as the original fireball, but smaller, and there's 3 of them. Now we have 3 different impact effects. The first one we've already created, so we just make sure it spawns as soon as it hits. So one of the problems we had on this effect is that we had a weird exponential curve for our expanding radius. See, I used the sprite size as the input, and the sprite size is on the frame before, so it'll feedback itself and exponentially get bigger. So using the initial one, remove the exponential thing. For this effect, I had 3 ideas. The first one was the most complex one, and for that it was thrown out, but the idea was pretty interesting. You record the position of an impact and then send it to the material, and then in there you can have a sine wave effect to get a impact. The second way I thought was, we'll put a decal on it. But as we've learnt before, decals don't work on transparent materials, and this is a transparent material. And the way I went for was the simplest way. We put a 2D sprite on the impact zone at a set angle, and it works fairly decently. Now, a lot of the FX materials are fairly simple, like this one, but some are a little more advanced than the others, and they have some quirks to them. The most advanced material is the shield one. It uses a procedural technique to create procedural hexes as a pattern. It's pretty cool. Let me show you its features. So the hardest part of this is getting the hex pattern to work. That's a lot of math. I'll show you in Blender. So, a bit of context. I have 2 versions of this equation. One in Blender, one in Unreal. I did the prototyping in Blender because it was simpler. Unreal's version works very similarly to Blender's, but it needed a bit of bodging to get it to work. So this equation has 2 parts to it. Both are basically the same. So we have our magic number. Our magic number, I don't know why it works, but it does work. We put that into the minimum and maximum of both wrap nodes, and for the top wrap node, we add it to the input value. This gives us 2 coordinate systems that are wrapped. One is offset by half of the coordinate system. Then we take the distance of all points, use a greater than node on both, then use that to drive a mix node between the 2 coordinate systems. So the rest of this material is fairly simple. The next most interesting thing is to get the pulses. We just put a sine wave on the text coordinate, and then you can screw around with multipliers and stuff to speed it up or slow it down. The other most annoying problem I ran into was the curve node. This thing. For some reason in Blender it's fairly simple. You just draw a curve and it'll do it. This thing you need a separate thing, and it's not explained well. The documentation is terrible. But at least it's in the documentation, like half the stuff. As far as other materials go, I've used power and warping the text coordinates on a lot of other FX materials to great success. It's very fun. But most of this, it's been smooth sailing on the FX side. So I've made quite a few PBR materials, and it was a fairly quick process. So we'll quickly go over them and discuss them. So the 3 I really want to talk about are the 2 statues and the ivy, which were the 3 that were meant to be like the main ones. So the ivy is procedural, and it was generated from splines and planes. The important thing from this is that Blender really doesn't have a good way of generating UVs unlike Houdini, so you have to get a little creative. For the leaves were fairly easy. They were planes and you can just take the UVs straight off the object. The curves are a little trickier. So for the X direction, you can take the length of the curve. For the Y, you can take the factor of the curve that makes the geometry itself. And then as far as using that data, if you want to export the data, well then you need to set an attribute on 2D vector and vertex edge. Then you just need to bake the object, which happens on export anyway. As far as creating the actual materials go, it was fairly easy. I took an image of a leaf, played around with it, and got it working. I took a simple wood texture, I played around with it a little, and got a fairly convincing stem texture. Both of those materials were originally created in Blender for prototyping, and then I had to remake them in Unreal, just because you can screw around with them more instead of baking them. As far as the statues goes, there's two of them. You have the iron one and the stone one. Both start off about the same. Prototype and create the base texture in Substance Painter. Play around with it a little in Blender to prototype it. Then remake what you can back in Unreal so you can get maximum configurability. I did the iron one first, which has the most configurability. The paint and the rust are set in stone, so annoyingly you can't change the paint color. But there are 3 other things you can screw around with it as well. The sun bleaching can be done by a object direction in the scene that pretends to be the sun's direction. That's all done through blueprints. We have procedural mud, which is separated into 3 things: dry mud, wet mud, and grass. And then the moss. The moss is also the only configurable thing on the stone one as well, as the stone is just the base texture from Substance Painter and the moss added on top. There's not really much to say. I've learned a good amount of Unreal from it, so I didn't really run into any challenges. I just sort of did it. Time for the last part to wrap this all up. The bridge. The bridge uses a construction script to instance and bend an object round a curve. As far as the object goes, I made it in Blender with geometry nodes, fully procedural, out of a single curve. It's nothing complex, it's just a lot of sampling a single curve. The tricky part for me was, no surprise here, Unreal, and getting the construction script to work right. Our tutor basically gave us the script for free and just asked us to do whatever we want with it. I did try and create it from memory, but it didn't work, even though when I looked back at it, it's identical to the original. I don't know what happened there. But one thing I found really annoying about the original is that you have to set the section length manually. And I wanted that to be done automatically based on the length of the object, so that's what I did. And because it's Unreal, it's never that simple. So this is the script to figure out the length of the object. So the main thing here is the bounding box. A dynamic mesh, we have a static mesh. So the first 4 nodes you see are converting the static mesh into a dynamic mesh. I'm guessing here, but I'm only guessing, is the first node creates the dynamic mesh pool. The second one requests a object from the pool, and then the big one adds the mesh from the static into the requested mesh, and then we can put that into the bounding box. And then it's fairly simple from here. You just sample one specific axis and get the distance, and then you can set it.
And now for something completely different.
Having people to give feedback is incredibly helpful. For instance, I got feedback on the way that rust and moss grows, which definitely influenced how I made those textures. I also got my brother to tell me about stone, as he's a geologist. We also have this wonderful Discord, where we can help each other with issues, and it's been invaluable. It's also nice to see what other people are doing as well. So yeah, my experience with Unreal, it just feels it feels different and fussy and a bit temperamental. But there are some things I do like about it. For one, I keep finding myself using the shortcut to create a multiply node in Blender accidentally. And that is it. We're all done here. Goodbye.